Alright, this is lesson 7.4 in intermediate algebra, inequalities involving absolute value. Alright, so we did some graphing with absolute values in the last lesson, or we did some graphing in the last lesson. We did some absolute values before that. And this lesson is combining both the absolute value and inequalities together. So if we have the absolute value of x and we say that equals 7, that means our x can be 7 or negative 7, because remember, the absolute value of a number is how far it is from what we're saying it's equal to. So if x is 7, that means it is 7 away from 0. And again, it doesn't matter if it's this way or this way. It's going to be 7 away. So let's look at some real quick graphs that they give us. They tell us that the absolute value is equal to 7. We have a choice on the number line of our point being either at 7 or negative 7, because they're both 7 away from the 0. Just what direction they go that we're concerned about with positive and negative. Alright, if we say the absolute value of a is less than 5, then we're saying that we're at negative 5 here and positive 5 here. The less than sign means that it is not equal to, but that number for a is somewhere between negative 5 and 5, because a, whatever number a is less than 5, which means basically the distance of a from 5 is less than 5. That's what that's saying. The distance is less than 5 units from 0 on the number line. So our answer is going to be somewhere in here, because any number in here is less than 5 units from 0. Okay, some of the numbers are on this side, some of them are on this side, but the fact remains they're still less than 5 units from 0. And if I have the absolute value of y is greater than or equal to 4, given my number line again, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Alright, what that's telling me then is that my y, whatever y is either equal to 4, 1, 2, 3, 4, 1, 2, 3, 4, or bigger than 4. The distance from 0 is bigger than 4. Okay, so that's what the greater than means. And for the most part, when you see the greater than sign in an equation, that will always be an or inequality. If it's less than, it'll be an and inequality. And we'll work with that in just a minute on exactly what that looks like. So let's look at example 1. We have 2x minus 5 is less than 3. Alright, translated, what that means is 2x minus 5, the distance, this is, from 0 is less than 3. So what that means, when we have a number line here, the distance from 0 will be less than 3. 1, 2, 3. So it'll be between here and here somewhere. But it won't be 3. That's why it's rounded. So 2x minus 5 is going to be somewhere between negative 3 and positive 3. Okay? We didn't solve for x yet. But what we're saying is that the expression 2x minus 5 is somewhere in there. Alright, so if we are going to make that a true statement, if 2x minus 5 is going to fit between negative 3 and 3, we have to find out what value x has to be in order to make that happen. I can't just put 20 in there, because 20 times 2 is 40 minus 5 is 35. And 35 does not fit between here. Okay? So 35 does not, or 20 does not work, because when we plug it in we get 35, and that's not within there. So what we're looking for in this inequality is what number can we put in for x, or what numbers can we put into x, that will make the distance of 2x minus 5 somewhere between negative 3 and 3. Okay, less than 3 units away from 0. So since 2x minus 5 has to be between there, let's write that as an inequality. Okay, so 2x minus 5 is somewhere between negative 3 and positive 3. So that's how I wrote that. And whenever you have an inequality that's a less than like that, you can make it into an inequality like this with 2 inequality. In fact, if you remember, it's called a compound inequality. And then we can solve for x by adding 5 to each side. So 2 is less than 2x, which is less than 8. And then we're going to divide everything by 2. And 1 is less than x, which is less than 4. So in order for this statement to be true, 2x minus 5 is somewhere between negative 3 and positive 3, then the value of x has to be a number somewhere between 1 and 4. So what we're trying to do then is find this, and then we graph it. So that's 0, that's 1, 2, 3, 4, 4, 1, and then so our answer is going to be x is going to fall somewhere between 1 and 4 in order for this to end up a number between negative 3 and 3. So let's try 2. 2 times 2 is 4. 4 minus 1 is negative 1. Does negative 1 fall in here? Yes, it does. It lands right there. Let's put 3 in there. 3 times 2 is 6. 6 minus 5 is 1. It's right there. It falls between there. So the numbers inside here, when you plug them in here for x, it will make this whole thing fit inside of here. Alright, so it's kind of a roundabout way of doing things. So let's look at example 2. 3a plus 7. The absolute value of that is less than or equal to 4. Less than or equal to sign tells me that it's going to be an and it's going to be a complex fraction, or a complex inequality. So what this says is the distance between 3a plus 7 and 0 is less than or equal to 4. So the distance 3a plus 7 is away from 0 is a number that's less than or equal to 4. Alright, so even if you don't understand all of this, when you get an equation or an inequality that looks like this with a less than sign, this is what you do. You write the absolute value without the absolute value signs there. You put a 4 there, and you put a negative 4 there. And there is your compound inequality. It's always going to be this symbol twice on either side of the 3a plus 7, and this 4, a negative and a positive. And then we solve for a. So we're going to subtract 7, subtract 7, subtract 7. Divide by 3, divide by 3, divide by 3, and we get negative 11 thirds is less than or equal to, a, which is less than or equal to negative 1. There is what my a possibilities can be, and then I need to graph those. So let's move this stuff up out of the way here, and we graph what we've got there, because it does say to graph it. Okay, negative 11 thirds is a little more than negative 3. It's almost 4. So we'll put that here, and we're saying that's less than. So negative 11 thirds is as small as we can get. So I'm going to make it square because it says equal, less than or equal to right there. And negative 1 is my other boundary. Can't be bigger than negative 1. So A is somewhere between negative 11 thirds and negative 1. So that is the graph. All right, let's try one with the or. That was an and where we could rewrite the equation fairly quickly, fairly simply, and let's use the and one. And the and one is when it's written as x minus 3 is greater than the number. The or is when it's less than. Okay, so what this says is x minus 3 is more than 5 units from 0 on the number line. So again, if we were to look at x minus 3 on the number line, and we've got 5 and negative 5 here, what we're saying is that x minus 3 is bigger than negative 5. 1, 2, 3, 4, 5. This way and this way. Now you'll notice real quick that a number over here, negative 6, is not bigger than negative 5. But the absolute value is bigger than negative 5. The absolute value of negative 6 is 5. So any of these numbers over here, even though they're negative, when we take the absolute value of them, they become positive, and they need to be bigger than 5. If we took negative 2, yeah, negative 2 is bigger than negative 5, but when we take the absolute value of negative 2, it becomes positive 2. Okay? Alright, so my answer is x minus 3 is less than negative 5, which is from here, or x minus 3 is greater than positive 5. Those are my two possible answers here. So when you get something like this, and there's a greater sign, you rewrite this, into two inequalities by taking the absolute value sign off, by writing it as, I'm sorry, I'm a little confused here today. X minus 3 is less than negative 5, x minus 3 is greater than 5. Okay, so when you have this, you're going to write it as the number without the absolute value sign is greater than 5. Okay, real easy. You write it exactly the way it is without the absolute value sign, and that's what we have here. The second way to write this, because again there's two answers, x minus 3, you switch the sign around and make it equal to its opposite, negative 5, and then we solve for x. So we add 3 here, and we add 3 here, and those are your two answers for x. And when you graph it, you have 0, and you say that x is smaller than negative 2, or x is greater than 8. And you notice there's nothing that overlaps. There's always going to be a space between your two possible answers. That's where the or comes from. Alright, so let's look at example 4, and we'll do that in the next video.